to continue doing and finishing the chapter of the electrical chemistry. This is the second lecture, and we got one more. So, what is it's called either like oxidative or oxidizing to be accurate, oxidizing and reducing agents. So let's take like each one individually and see what is the difference between them. So when you write a redox reaction, there must be like an oxidizing agent and a reducing agent in the equation. So reducing agent or reduced agent is a substance that has the ability to reduce another substance. So which means that it loses electrons, okay? It's oxidizing, okay, or its oxidation number increased. So as we mentioned previously that when like an oxidizing like a process takes place, which means that the oxidation number increase and there would be like a loss of electron, okay. Now, the oxidative or oxidizing agent is a substance that has the ability to oxidize another substance. So it gains electrons. So its oxidation number decreases. So it's reduced. So it's the vice versa, the opposite of the reducing agent. So let's go through these equations and see what happens. So let's start with the copper on the left, okay? And we know that the oxidation number is 0 for a free element right here, okay? And now let's talk about the nitric acid, 4HNO3. So let's start with the oxygen. The oxidation number of oxygen is -2, which is known, okay? So 3 right here times -2, which is the oxidation number of oxygen, gives us -6, right? So there must be like a +6 on the left side in order to get the formula balanced or equilibrated. So we know the hydrogen is the +1. So what is remained right here is the nitrogen. So the nitrogen would be +5, the oxidation number of it. Okay, it's just like we are going to count them, and then we will go to the product and see what happens to the nitrogen oxygen, whether they are reduced or like oxidized. So let's go to the right side and see what happens to each one individually. Now, we need to know what happens to the copper. So for the copper, it's reduced, okay, or it's called the reducing agent because it was oxidized. When we say this molecule or a particle or a formula or like an element is oxidized, it means that the oxidation number increased, okay. So if we see any oxidation number increased or an increasement in the oxidation number of an element, we'd say like this is a reducing agent. So with a reducing agent there is like an oxidizing happened, okay, which means that the oxidation number of a substance increased. So for the copper right here, its copper is a reducing agent. Why? Because it's oxidized. It transformed from Cu, okay, let me just highlight it, from Cu with 0 oxidation state into what? Cu plus 2. So the oxidation number increased. So it's oxidized. Let's talk about the nitrogen right here. So for the nitrogen, from here, what happens to the nitrogen? It transformed into +4 and it was +5. So what happened to it? Its oxidation number decreased, which means that its oxidizing agent and it was reduced. The oxidation number reduced, like it gets down, okay, from +5 to +4. Let's take and go through this example and see like how could we determine the oxidizing agent and the reducing agent depending on what happens into the equation. So for the zinc right here, and we have copper sulfate, okay? Now it gives us ZnSO4 plus Cu. So we will be counting each one individually, and let's say like what happens to each one. So we have to write down the half equation of each one and see what happens to each one. So for the Zn, what it was 0, okay? It lost or gained electrons. It must be gaining electrons, okay? Because for the Zn right here, it was 0 and it becomes Zn plus 2, which is obvious because when we replace the copper right here in the first equation, okay, with the zinc, okay, it becomes Zn plus 2, and SO4 it was minus 2, okay? So the zinc right here gained 2 electrons, okay, which means that it was oxidized, okay, or reduced. It's reducing agent and it was oxidized because it gained electrons. However, if it was the opposite, like with the copper right here, so the copper was plus 2. How did we know it was plus 2? Because it was bind to the SO4. The SO4, its oxidation number is minus 2, and the copper must be plus 2 in order to be like equilibrated. However, like for the Zn, it was like as a free element. It was not bind to any other negative partial or partial negatively ions, which means that the copper right here was plus 2 and it became 0. So what happened to the copper right here? It was reduced, which means that it's an oxidizing agent. So an oxidizing agent is reduced and it lost electrons, okay? And the oxidizing or the oxidation number of it is dropped down, which means it reduced. Let me just summarize this in order to get like the point. So with an oxidizing agent, there's a reduction, which means losing of electrons. With reducing agent, there is an oxidation, okay, which means there is like an increasement or gaining electrons. This is a summarization of what have been said. Let's move to the second one, Cu plus 2AgNO3. For the Cu 2GnO3, like for the copper right here, it was 0 and it becomes Cu plus 2, which is reduced, which is like an oxidizing agent. And for the second one, it's the same as the previous one, 2Ag plus 2E, 2Ag, and it was plus 2 plus 1, and it become like a 0, so it's an oxidizing agent. All right, it's easy. Now let's move to the electrical cells. So we have like more than one types of electrical cells. We will be considering like 2 or 3 of them, and then we will go through each one in details. Let's like see any electrical cell, from which stuff or what are the components of any electrical or electrochemistry cell, okay? Or so we have 2 different types of electrochemical cells. Each one consists or must consist of 2 like main parts. The first one is the anode, which is the positive pole, okay, and the second one is the cathode, which is the negative pole. So an anode is the positive pole of the electrochemical cell, that the oxidative or oxidizing process goes into it. So it's the source of electrons. Cathode is the negative pole of the electrochemical cells, that the reducing process goes into it. So the electrons that are produced by anodes, or in general anodes, transform to it through an external wire. So we will see that like when we study like Daniel cell and the other types of or other electrochemical cells. Now, so the electrochemical cells are divided into either like galvanic cells or Daniel cells, as we mentioned previously. So what is a galvanic cell? So we will talk about it, study it in details, and then I'll send you like videos explaining or showing you how it works, the galvanic cell. It had like, or it has like more explanation. So a galvanic cell is the cell that is, or inside it, the chemical energy transforms into electrical energy. So for like with any cells, so there will be like a transformation of a chemical energy. So we will be using like chemicals or compounds. It could be salts, okay? And we want to transform those salts into like electrical energy through a spontaneous chemical reactions. So there will be like a reaction. So any chemical cells or any electrochemical cells, there will be like chemicals, okay? And we will be passing an electrical current through that cells in order to do like a transformation, like from those like energy, from the chemical energy into an electrical energy. Um, so this like, for example, we have batteries in general. So the oxidizing or oxidative and reducing a process inside the galvanic cells. So we will explain this one, okay, and I'll show you the video. When a strip or piece of zinc is submerged into a like a blue copper sulfur solution, so the zinc strip begins to corrode. That is accompanied with an increase in the concentration of the zinc ion. So a spontaneous reaction occurred right here. At the same time, a brown layer of copper begins to coat the zinc. So there will be like a zinc coating. Okay, so we will be like indicating what happens into like the cell by the color change, okay, or the coating change, okay. Um, a portion of copper is deposited into the bottom of the ball, okay, so it will be like a precipitate, okay. The blue color begins to disappear as a result of the decrease of copper ions. So when the copper ion like decrease, so it will be like a blue color begins to disappear. So the disappear of like the blue color means that there is like a decrease in the copper ions. So eventually the color becomes or turns into a colorless. So there will be like no color. So and the reaction is complete. So the equation of like the galvanic cell is Zn, okay, the zinc with copper sulfate, okay, gives us copper and ZnSO4. So I want you to write down the oxidizing and reducing agent and determine which one was oxidized and which one was reduced based on this equation. So the sulfate ions has not changed through the process, so because they are not involved in the process. So it's kind of like a single displacement. I don't know if you guys still remember the types of reactions when you like had it in the second grade, okay. We have like double displacement, okay, and we have single displacement. This is a single displacement, so the Zn replaced or exchanged with the copper, and the SO4, the sulfate ions, has not like affected.